So we've talked about voltage. Now the word for voltage is potential difference, and that's how much energy the electrons have. We've talked about current, and current is measuring how many electrons are passing a point every second. And the third thing we need to talk about is this thing called resistance. Resistance is the opposition to flow, so anything that's going to slow down those electrons. So when electrons pass through a device that uses their electrical energy, they experience an opposition or resistance to their flow, which results in the loss of energy. Resistance, the symbol for resistance is capital R, and it's measured in this weird unit. It's a Greek symbol, ohms or omega. It looks like the Lululemon's symbol that you see on clothing. So there's four things that affect resistance. Length, so how long the resistor is. So the longer the resistor, the more resistance. How wide it is. So it's actually interesting. The wider it is, the less the resistance. The density of the material, the denser material, well, it's harder for the electrons to navigate through the small spaces in between, so it actually increases. And also the temperature. The warmer something is, the more resistance it has as well. So the rules for resistance are this. So in a series circuit, remember, series circuits is when one part comes right after another. So all the electrons have to go through the first part. All of them have to go through the second part. All of them have to go through the third part, and then back to the battery. So T is what we use for the battery, kind of stands for total, but it actually is what happens at the battery. So in a series circuit, the resistances all add to give you the total. So in this example here, if I wanted the total resistance in the circuit, I would just add 100 plus 200 plus 200, and that would give me 500. So in a series circuit, the formula is simply R total is equal to R1 plus R2 plus R3. In a parallel circuit, parallel means there's options and branches. So the electrons could go down this first path or they can go down the second path. Well, the formula is a little different. It's 1 over R total. And we never want at the end to be the 1 over. So you have to flip that in the end. But anyways, formula is 1 over and then however many parts you have. 1 over R1 plus 1 over R2 plus 1 over R3. In this example here, there's only 2 parts. So I go 1 over R total is equal to 1 over R1 plus 1 over R2. And then I plug my numbers in, 1 over 100, 1 over 200. I'm adding fractions, so I need a common denominator. I'm going to pick 200 as my common denominator. So to make the 100 into a 200, I times the top and bottom by 2. So that's where this 2 comes from. Plus, I didn't do anything to the second one. So I now have 3 over 200. Except that's what 1 over R total is equal to. And I don't want R total on the bottom, I want it on the top. So if I flip the left side of this equation, so I put R total over 1, I have to flip the right side, so then it becomes 200 over 3. It gives me, when I punch that into my calculator, 66.7 ohms. 66.7 ohms. And again, the ohm symbol kind of looks like a horseshoe. It's the omega or the Lululemon symbol that we have. So I just want you to try a couple of questions out of the textbook on page 527 and 529 for resistance.